you go. Go live. All right. My software is saying you're live. Hopefully everyone can hear me, and hopefully people are here to show up for miscellaneous APIs. How exciting is that? Okay. So I will hang out for a few minutes here, and I'm going to go through some miscellaneous stuff today and just talk about arbitrary questions that people might have, and start looking at actually the least miscellaneous thing I have idea for today is talk about the command world. I'm also calling this the CLI world. There's kind of a bit of ambiguity about what do we actually call this thing? Is it the command world? Is it the CLI world? Is it the CLI command world? I think the what is it concept for this world is going to be like it's what you expect from kind of a typical command line environment and the kind of program that would run from that, which includes things like servers, includes things like traditional command line utilities you'd run and stuff, but also things that would run in kind of a disconnected, server-like way. And the main functionality set is like it's got access to a file system, it's got access to sockets, and can do all the traditional things: command line environment, command line arguments, environment variables, and potentially some other stuff. So let's take a look at what the other stuff is. I'm going to set up screen share as I do with WASI CLI. So this is just my own proposal, my own repo. There's actually a vote coming up at the next WASI subgroup meeting to approve phase 1 proposal for this. We've been talking about it for a while now, and it seems like people think it's a good idea in general, so I'm hoping that the vote will be positive. But the idea here is just, actually I still have all the proposal template content in here, but I got some WIT stuff I want to talk about here on the stream. So we got 4 files here. First, let's take a look at the WASI CLI. Oh my goodness. What is going on here? So GitHub has rendered this in an interesting way. Oh, I called it .wit.md. I wonder if it's possible to rename from the GitHub UI here. There's some discussion going on. There's a PR open on the WASI proposal template repo about should we have markdown content inside of WIT, WIT inside of markdown content, or should we just have WIT files? So should we do .wit.md or should we just .wit? And so I have a PR up to the, currently like the proposal repo uses .wit.md. I have a PR up which changes to .wit, but talking with some folks offline, some people like it actually is .wit.md. So we'll kind of see where we end up there. And unfortunately it means that a lot of the things, all the repos are out there are kind of in a halfway state right now. So this particular file is just WIT. There's no markdown here. But actually, in this case, it makes it kind of easy to see what the actual content here is. So let me zoom in on this a little bit and make sure that we can see this in the stream really well. Hopefully, people can see the browser window I've got up here and see what I'm talking about. If not, please ping me in the chat. All right, so this is a quick look at what a command, or what might be eventually called the CLI world, might look like. And this is just a quick glimpse. I don't have sockets in here yet. That would be one thing that's missing. And there's some other things that I'm going to talk about a little bit later that also might want to add to this thing. But it kind of shows you, like, here's a default set of APIs you kind of have available in this world. You can think of the world like the virtual world. Like, here's the set of things you can do. And worlds are very much an allow list situation where, like, these are the things you can do and there's nothing else you can do. There's like no extra stuff. So this kind of explicitly lays out, here's all the things the command can do. So you can't go and dig through the operating system APIs or just like figure out whatever you want to do in the system. You have to limit yourself to talking to the APIs that we provide. And so here it is. So we got clocks for telling what time it is and for measuring time. Default clocks. I can actually talk a little bit about the clock to default clock split a little bit later here. Logging, kind of interesting question if that belongs in the CLI world or not, but it seems like a useful thing. A lot of people like to write code that uses a logging API with a little bit more structure than standard error. So WASI logging provides that. And it can work in a command line environment. We can just send it to standard error. It also turns out to be useful to have a dedicated standard error API. Files, random numbers, polling for I/O, I/O streams, and WASI exit is a thing which is not an official WASI proposal yet, which I'll be talking about here So standard error and exit are two things that are not officially WASI proposals yet, but I'm going to talk about them here as possible ideas I'm going to propose going forward. This world then has an exported function. This is sort of like the entry point for all components that would implement this world would have an export, a function named command, and it would have arguments for the input stream and output stream, and then a list of strings for arguments, and a list of tuples of string for environment variables, and a set of preopens. So this is very much in development. There's a lot of things that are in flux about this. One of the things that's in flux is potentially the name of the command function. That might get changed. That's completely a subjective question, but it's sort of useful to have nice names for things in the end, to have things that mean something. Environment variables and preopens. It's entirely possible that these will move from being arguments to the command function to being what will conceptually be value imports, but we don't have support value import in WIT yet. So we might actually end up having these be as being imported functions that just return, have no arguments, and just return a list of tuples for environment variables and a list of these tuples for preopens. Okay. With the .WIT extension, could we have a custom viewer with the GitHub blocks, just the same preview invite? Yes. So a lot of the stuff that's going on with WIT right now is sort of limited by the tooling and the user experience, all that kind of stuff you get right now with WIT is pretty much limited by the fact that WIT is a new format and there's just not standard stuff. Like you can't do a triple backtick WIT in Git and have it do a magical, nice, pretty thing. That stuff will happen over time. This is kind of the nature of building a new format, is that we don't have all the tools knowing about it yet. But we'll get there. Definitely that's a place where we want to go. Okay. So what I want to do is I want to pull this into HackMD, and I want to edit this file. And I want to edit, it's going to be a new note. We're going to pull from GitHub. The repo is sunfishcode/wasi-cli. Oops. Okay, I gotta confirm that I can access my new repo here. Two-factor device offhand. I don't know that I have it, but what I can do is edit this thing in the GitHub UI, which won't be quite as pretty, but let's see if it can work. Edit. Oh, this is an editor. I'm in an edit view already. Oh my goodness. Okay, so one thing we want to do here is the preopens right now is this list of tuples of descriptors and strings. So this descriptor gives you a handle to a file or a directory, and the string tells you the path that you expect to see that at. So eventually we're going to add sockets to this set. Hopefully soon, in fact, we'll add sockets to this set. And I'm expecting that we're going to want to be able to add in pre-open sockets as well. And so one thing that might look like is a variant. And so a variant can have multiple values. It's going to be file. And if you get a file, the thing you want for a file is to know what path it represents. So tuple of descriptor string. If you get a directory, same thing. We talked about yesterday, there's some dynamic typing in POSIX, so we have a single descriptor type could refer to a file or a directory. And technically, we wouldn't even need to have separate entries here. We could just have just like a descriptor that give you both. But it's handy to tell programs what they're getting. Like here's a file, here's a directory. It actually lets them be a little more efficient. We don't have to do an extra equivalent of fstat to find out the type of things, just to categorize it, we can just know up front. So we can just tell you that up front. So we have these 2 entries for file and directory, and we might also have this is potentially going to be iterated on, but you might imagine having something like network, which might be a tuple of just keep it simple for now, IP address and a socket. Yeah, so this would be a pre-open network, which is a, or actually no, it's a socket. It's going to be a network handle. We'll do a socket later. So this could be a network handle saying if you want to access this IP address, and maybe it'll be a set of IP addresses, then we'll associate this handle with it and be able to pass it in, and then have libc do the same thing it does for pre-opens. And then you could have a similar thing for socket. So you could pass in a socket. So then libc could also allow programs to attempt to create a socket and then have it remap this to a pre-open socket. There's a lot of details to be figured out here, and I don't have the complete design. I just want to sort of sketch this out. And if we do this, then this list of pre-opens turns into just list of pre-open. So how that would work. So they can pass in different things into main. All right, and then the next step, potentially in the evolution I just mentioned, potentially doing value imports or doing a function. This actually might turn into there's a function that we call default preopens that would give you a list of preopens. A little bit subtle here. This looks like an ambient authority because it's taking no arguments and it's giving you a thing which has including handles in it. So you kind of get handles from nothing. And so you could say, well, isn't this an ambient authority? Why do we have this? And so there's a few different ways of thinking about this. One of the ways that this is what we call a link time authority. So programs don't have the ambient authority to access anything they want. They can only access the things that are provided to them in the imports. So start a component, and it can't magically reach out and access the file system unless someone who has instantiated it has provided a file system API. And so in terms of capability-based security terms, we can say that even link time authorities like this are still refusable. That someone can still interpose and say, I'm not going to give you the whole file system. I'm not going to give you everything. I'm going to give you this default preopens, which can have anything I want in it. I can still interpose that and control what things our component can run in. So we can still have an untrusted component. It can still have untrusted code. In the future, what we expect is instead of this function, this will just become default preopens. Will just be a list of preopens. Instead of a function that you call to get a list, it'll just be a list you get provided with upfront. This is a little bit nicer because you don't actually have to call a function, and you don't have to worry about thinking about, do I get the same value each time, or should I call this function multiple times? When do I call it? It's just provided to you as a list just upfront. It's a little bit nicer representation for this. All right, check up on my comments here. Command world of worlds, a command multiverse, yeah. Push period to open up the VS Code editor. I'm browsing when looking at the file. That's true. I'm not super up on these latest Git IDE things. All right, I'm going to cancel these changes, and we'll talk about those actual. We'll make those actual changes later. If I pull this up and say dot, does this work? Pull up the IDE. It's not working for this file. Oh, now it goes. Setting for web editor. So this is, you're watching live in the stream. I'm trying this out for the first time. Pulling up the GitHub IDE here. And there it is. There's our file. Even sort of syntax highlighted it. Kind of guessed that tuple and string and descriptor are keywords, although it sort of is confused because it thinks string is green once and blue another time. I guess it's trying to do a markdown highlighting, so it's really confused about our syntax here. So yeah, so the same thing here. This is the same contents here. Let's jump ahead to the next interface that I want to talk about here is WASI exit. This has also kind of been something that's kind of bounced around. We haven't historically had really great answers for this about how should an instance exit. If it's a command style program, it's a typical thing. Exiting is a typical thing that commands can do. Anyone from anywhere inside of a process can call exit, and it just ends the whole process. Which is kind of weird. Like you kind of have to have like these ad hoc conventions saying like if you're writing a library shouldn't ever call exit because a library doesn't necessarily know what the application around it is doing, and so libraries wouldn't be expected to tear down the entire application with an exit call. So exit is kind of this anti-modular function in a way, but it's still a necessary function because application writers are writing large applications and they expect at a point where they know that if they're the ones writing the application, they know where they want to exit, and they expect that to work. So we need to have something. One way of modeling exit is to have it be a stack unwind. If you think about the exception handling proposal in WASM, which is now either at stage 4 or it's approaching stage 4, which when available will allow WASM programs to do an unwind. And if we can have the exit function call, simply do an unwind all the way back to where main got called, and then main can return. That basically has the behavior of an exit function call, which would be kind of an elegant way to do it. We wouldn't need to have a special function. And it wouldn't need to have kind of a special relationship between different instances. We could just say, exit means you unwind back to your main function and return. So it doesn't really need any kind of special semantics. But unwinding isn't quite available in the tools we have available to us today. It's not implemented in many of the non-web engines today. And so the current thinking about how we can do this in the short term is we can have an interface which just gives you a function. And the function takes an exit function, which just does an exit. So sort of under the covers in host code, we'll do the equivalent of what eventually WASM will do, is unwind back to main and have main return. One interesting thing with the exit function is there's an argument to exit. In POSIX, this argument could be an integer, which is typically, the argument to exit function is int. But of course, in Unix, they basically say like you only really get 8 bits of that int are significant to return to the OS because the wait system call doesn't have that many bits to give you, so it only give you 8 bits. And then within those bits, like the high bit is kind of reserved for special handling, like of signal handling return values. So if your program exits with a signal, then you're expected to return with one of the higher bits values. And so that's kind of you probably don't want applications just like randomly using those values in that range. And then in the low 7 bits, you have this kind of like 0 means success, and any other value probably means failure, but not always. And the failure is going to be different depending on if you're on Unix. There's a certain set of codes that there's actually this thing called sysexist.h, which kind of defines some somewhat standard error codes, but they're kind of weird. And then Windows has a completely different set of error codes that it can return. And so if we look at WASI, we want portability. We want to have programs that can be portable across Windows and Unix and other environments. And so we really want some kind of like semantics for, if I say return or exit with the value 7, how should the environment interpret that? How should that get propagated out to the outside world? And if you don't have a knowledge of the platform you're on, it's impossible to know what 7 will mean to someone who's calling you. And so the proposal here is we just completely reduce it down to this result. And result is actually a built-in type. Typically in Rust, results would have, not in Rust, but in RIT as well, would have 2 arguments. Like you might have this sort of a silly example. So there's 2 types that get passed to results. There's a value type, and for the success case for result, and there's an error type for the error type of result. And typically the result will be a return value, but here we're going to use it as an argument. And if you leave these arguments out, that result with no angle brackets is sort of equivalent to a result with nothing in there. So like the default value is something we sometimes write like this, such as like result with no values in it. Which in the end basically means that this result type with no values in it is essentially just a fancy Boolean value. It's just a Boolean value that tells you, did it succeed or did it fail? Because in the success case, you don't get an extra value. In the fail case, you don't get extra value. There's these empty types we put in there. So from a portability point of view, this says that if we have this kind of API, it means that applications can't return other exit values. They can only return success, which on Unix would be 0. Windows too, but there are platforms which have other success values. And a failure, we'd probably return the value 1 on Unix, which is sort of widely recognized as a failure exit code. And Windows, we would pick whatever the appropriate Windows code is. And so this is kind of interesting departure point from POSIX, where POSIX would say that, like, well, you have this integer, you can return whatever you want, and the environment will get this value. And now, in order to be better portable, this proposal would be to say, we just get a success or failure condition. It's a little bit less expressive, but it does mean that for a portable program, we don't have to worry about who's calling me and what are they expecting this value to mean. I don't have to have some kind of implicit arrangement with the caller or some kind of special arrangement to say what these values mean. I could just say, like, I'm either going to succeed or fail, and everyone knows what succeed or fail means. If I go back to my WASI CLI.wit, I didn't actually mention this before, but this function goes along with that exit code. The function returns a result. So it's also a success or failure Boolean value. And so WASI exit would be, you pass the result, and this is the result that would then return from that command function when the function returns. So the semantics of this would be unwind back to that command entry point and return this result. If we really wanted to, we could probably go through and try to figure out some other exit codes that could be implemented in a portable way. But it's actually pretty tricky to think about, like, what would be the exit codes that matter in a program to someone calling it. You certainly care about, like, did the program succeed or did it fail? But if it failed, is it possible to have an exit code that sufficiently describes that failure to allow callers to do interesting different things based on it? If the program does fail, probably the program will also describe what happened to its standard error, which will probably be much more descriptive than anything we can return in a single exit code here. And so definitely we want to have the standard error for the descriptive, like, I couldn't open this file or I couldn't do this thing, and here's all the information you need to know about what happened. And the error code just needs to say, like, yep, it failed. Take a look at the standard error to see what happened. It's going to be the typical use case. So the challenge, if we want more error codes, is to think through what other values are useful to return, that are useful to have in environments that are sort of not redundant with what you'd express in the standard error. So that's kind of what motivates this interface. We'll move on to WASI standard error. This is also not in an official WASI proposal yet, but hopefully we'll propose it soon. Although it might actually even have to change, because there's some stuff in here that might not actually stay there. So WASI standard error. Also kind of evolving a little bit. We have an API called WASI logging, and WASI logging has extra stuff in it. It's like similar to WASI standard error that you can, like, print messages, except in WASI logging, there's a couple extra things. There's a log level. You can print logs at, like, debug or warning or normal or different levels of logging. WASI standard error doesn't have the levels. The logging API also has a context parameter. We can sort of give it an extra string to help the consumer of the logs understand different kinds of logs that you're printing out. In standard error, there is no context, because this kind of models like the actual, like, Unix standard error or even C standard error, where you just print strings out and there's nothing there. WASI logging also kind of has a concept that every message kind of is self-contained. You call a log once, and the expectation is that the log message will sort of fit on a single line of a log message. And the log message shouldn't end with their own new line. In standard error, that's not always the case. In standard error, sometimes people deliberately print strings that either don't end a new line or have, embedded new lines that have multiple lines in them. If you don't end a new line, it's typically because you're printing out the standard error in parts. You're going to print out a message and print out more and more and more, and kind of build up a line in pieces. And so this WASI standard error API allows you to do that. It allows you to just print any kind of string to WASI standard error, and it doesn't have to have a new line at the end. It doesn't get a new line added automatically. That's what this print is doing. It's an interesting question about why is WASI standard error not a stream? And so why do we have a dedicated APIs that are like passing in another output stream into the program, kind of the traditional POSIX thing to do? And the observation here is that standard error for commands is typically used for informative messages that are not related to the program's primary output. And so in this case, for these messages, it's not useful for the program to be thinking about the failure potentially blocking, or the log potentially blocking, or potentially being async in the future when streams become async, or potentially having errors. This is just sort of like, we want to send strings out to the standard error and forget about them. there are two functions here. After just printing, we have an isTerminal and a num column. This is kind of getting into terminal functionality. If you look ahead in my window here, you can see I have a WASI terminal.wit, which will eventually be where we start doing the sort of full terminal thing. So what you're seeing here in this WASI standard error is actually an older kind of version of the terminal API. It just gives you two things: is it a terminal or not? And if it is, how many columns do you have? And this could be used to do things like many CLI applications will have a progress bar or a spinner telling you, download progress or some other kind of progress thing. Or you can have color output, that kind of thing. So you could imagine this could be the start of an API that could support that. Typically, those programs need to know, is it a terminal or not? Because if it's not a terminal, there's no reason to do a spinner. If it is a terminal, you often want to know how many columns, because if you want to do a progress bar, it's kind of nice to have the progress bar be the size of the terminal window that you're in. So this is a start. These are just very minimal functionality pieces here, probably too minimal. And so probably the full answer to terminal is going to be in this WASI terminal.wit. I haven't actually published this particular file as such anywhere yet. So if you haven't ever seen this before, don't feel like you missed it, because this is the first time I've talked about this at this level of detail. And I'm not 100% sure that this is going to make it in time for everything that's going to happen with WASI in the Preview2 timeframe, but just want to put it out there to see if there's kind of interest in this. Actually, before I launch into that, let's go back and grab this question about exit. What about partial success? Is it special enough to deserve special treatment? I think for partial success, I think what I would say is, like, if you look at the way existing commands work in Unix, you can either return 0 or you can return some non-zero value. If you return 0, that means success. And maybe there was some failure in there, but it means the application said, overall, I succeeded to my caller, and the caller can treat that as a success. Maybe not everything I was asked to do succeeded, but the expectation was that those things could fail. So I call it a success. If I return a non-zero value, then I've failed. And maybe part of my work has succeeded, but overall there's a failure. And again, I should describe what actually happened to standard error. So it feels like the expectation for a CLI environment is already that you have to declare I either succeeded or failed as like a single Boolean thing. And if I failed, then the caller might want to dig into, okay, what happened in the failure, partial success. But an exit code isn't really going to be sufficient to describe, like, if you partially succeeded, maybe I want to know which part succeeded and which part didn't. Especially if I have an integer error code, there's kind of no way to really encode, I processed all these files and some of them succeeded, some of them didn't. It's hard to express as a single integer. So the best we can really do is, like, if you didn't process everything that the caller was expecting you to process, like, it's not part of your contract that things could fail. It's part of your contract that you're supposed to succeed completely or whatever, then you have to return a failure code, and you can still have a standard error that can still explain whatever actually happened. If some of these things succeeded, some of them didn't, and overall I failed. Or some of these things succeeded, some of them didn't, and overall I succeeded because I wasn't expected to have everything succeed. Kind of the two main cases. So it's kind of my feeling that, like, there's just a single integer is really just too limiting. It's my theory that this sysexits.h is this thing that they have in many Unix platforms that attempted to define a set of standard exit error codes. Except that what happened with that API is that it's just not very useful. It was sort of extracted from, like, an old, I think it's like an email processing server, is what it looks like. And the error codes are very, very specific to that server. And there's never been an attempt to, like, define a new set of standard error codes. And my theory of why that's never happened is that it just wouldn't be that useful. There's actually, it's the kind of thing that, like, and I've fallen into this trap too, of thinking, like, well, of course there's going to be a situation where you have standard error codes that everyone should just recognize. Or we should just define a set of standards that everyone can follow, and then you can interpret those correctly on Windows and translate them something on Windows. But it's never happened. And so I think it just turns out that it's just not as useful as it seems like it is. And that's why we can get away with having a single result in the command.wit exit value. All right. So I'll do a quick scan of WASI terminal.wit here, just kind of just give a sense of how this works, or what the idea is. It's like, this is so new, it hasn't even been run through WIT yet, so I haven't even converted the resources to pseudo resources yet. But Just a rough sense of how this works, just kind of give a taste of how the WIT API works. So we have a resource for an input terminal. So this is splitting input and output sides, because some programs deal with terminal input and don't do terminal output, or just do regular output. There are other programs that do terminal output but don't have any terminal input. And then there's some programs that do both. So we have separate resources for input and output. And the input, there's one method that you can apply in it, at least in the current APIs, is to catch out here, which is a set input mode. And so there's a couple of input mode flags. Go down here to see the input mode flag. And so there's like two modes for terminal input that you can set. One of them is immediate mode. That's kind of the terminal mode where when you type a key in the terminal, the application gets that keystroke immediately, rather than sort of waiting for the whole line to be typed in. So like when you're in an interactive editor, like you're typing in Vim, or you're typing in something that like you press a key and something happens immediately, that program has put the terminal into immediate mode, or sometimes called non-canonical mode. Whereas if you type like into a raw terminal, it'll actually, you can type all you want. It'll actually type into a buffer, and the terminal won't send it to the application until you press enter. It'll take a whole line and send it to the terminal as a single line. So this is a pretty standard feature in Unix terminals, to have this immediate mode where we can type in to have an interactive terminal application. The other input mode is hidden, where this is for like entering password fields, where you want to have the default behavior for terminals is if you're typing things in, it'll echo the character back so you can see what you're typing. But if you put it in hidden mode, then we disable that echo. So you just type things in and it doesn't get echoed back to you. Those are the sort of two main input modes. So this just kind of comes from me looking at terminal APIs, trying to figure out, like, is there a small set of things we could do that would capture most of the use cases? And it seems like these two things, if you look at the actual, like the full TC set adder function and the terminal settings, there's a whole bunch of other settings you can set. But these kind of two flags kind of capture the two main things that most applications want to do. So it's kind of a simplified take on it. Maybe over time we could add more features, but this is a good place to start. All right, so we also have an output terminal resource. That's a little bit more involved. More things going on here. So the first thing is a set of features. And so output terminals, there's actually kind of different groups of functionality that are associated with output terminals. I've actually sort of grouped things into color feature. So color can be enabled or not. Line-oriented editing, which is sort of like manipulations you can do with the cursor on a single line. So if you think about like progress bars tend to be like line-oriented, or like line editing programs for things like read line, edit line kind of things are all what we call line editing. So it's like on a single line, it's not moving the cursor up and down like a cursor adjustable, a fully adjustable screen. It's just like you're moving the editing the single line that you're on is a feature. Then for moving up and down, we have what's called full screen mode, like fully like two-dimensional addressable cursor movement. Full screen mode, and then we have custom title. Is the ability to set. There's an escape sequence in terminals you can that can be allowed to set the terminal title, like on the window title in your window manager. So we're sort of being careful about, like, we don't just want to give all the abilities to programs by default. We want to have them import a function which sort of statically declares they'll be using these features, and they have to call this function to enable those features. This is kind of motivated by that thinking about untrusted code, because the ability to control a terminal can actually be potentially dangerous in the hands of fully untrusted code, especially if you have things like full screen mode. It can be difficult to tell the difference between a terminal program that is exited and a terminal program that's still running and just showing you your prompt and then collecting all the things you type in from that prompt, or a terminal program that can go and edit the history in your terminal window. Right? These are the kind of things you can do if you have like full screen editing mode. Whereas I think by default we want to have programs that run that don't have that capability, and they can opt into it, and we can interrupt that. We can interpose on that ability to opt into it if you don't want to allow them to do that. Same thing with custom titles. If you can set a custom title on your window, you could potentially confuse people. It's not immediately a security hazard, but these are all things where you can potentially confuse someone who's typing commands, and this could be potentially part of phishing attacks or other kinds of attacks where you get people to do things, social engineering kinds of attacks, to get people to do things where they're confused about what they're doing. All right, so we have these things to enable the features, which is just basically saying, like, by default, if you print to anything with a terminal in it, we're not going to interpret those escape sequences. But then if you call these enable functions, that requires you to import the function which statically declares that you'll use it, and then dynamically call it, which says I intend to be using this. So there's plenty of opportunities for us to say no if we don't want that to work. Then there's a couple of accessors. Color support is just a query function that queries, returns a tuple of a color support enum and a color preference enum. So let's go to the bottom here. Color support tells you what kind of color support. Terminals have different levels of support. There are monochrome terminals, which aren't super common anymore, but they exist. 16 colors is sort of like the old school ANSI escape sequences that a lot of things support at this point. And it's kind of there are other modes of color as supported. This is also somewhat of a simplified API. We just jump all the way to 16 million colors. So it's sometimes called true color in the terminal world. You basically get an RGB, and you can kind of pick whatever you want. So these are kind of like the 16 colors works just about everywhere. Monochrome will work absolutely everywhere, and 16 million colors will work some places today. So this is just telling you what kind of colors you have, so you can know what to expect as an application. And the other enum you get is a color preference. There are users who don't like it when applications print lots of colors all over the place. And so kind of there's this idea that the color preference is distinct from the color support. The terminal might support colors, but the user might not want them to use it by default. Like, don't use colors unless I ask you to. So in fact, there's a whole website called nocolor.org, which is about trying to standardize an environment variable called nocolor, which can put applications in the mode of don't use color by default. And so in order to avoid depending on environment variables, this is actually sort of proposing that we just bake this in and have an API that returns you the color preference of the user. So don't use color by default, or go ahead and use whatever colors you can by default. It's kind of the two choices we can have here. I guess in theory we could have like a never use colors option, but that might be more like just use color support monochrome. So that's colors. That's the query function we can get from colors. You also have another query function for the number of columns. Again, that's useful for line editing use cases where you're not going up and down, you're just going on a single line. And then there's a lines and columns function for querying the lines and columns. That would be for full screen mode. So this is just like a possible API. And then there's other features you can do, but everything else you can do in the terminal API would be done through the escape sequences. And I have a proposal or some documents out there in various places kind of proposing a set of escape sequences. And so there's an interesting kind of policy question here of, should we just allow escape sequences to go through to the host terminal, or should we require WASI environments to parse the escape sequences and preprocess them? And I don't know the best answer here. This is kind of a tricky question because parsing those escape sequences is pretty complex. There's a lot of them because we got color, but also there's like color cursor movements, setting the title, clearing the screen, resetting the screen, terminal attributes for things like bold. There's lots of different escape sequences out there that can do lots of different things, and it's a bit of work to parse all those things. Expect all programs to always go through that. But if we don't do that, if we say that you can go through the terminal you have, then we have portability problems. Then we get the situation where Windows, which has some support for ANSI escape sequences now, but some of them are different than how Unix works. But even on Unix, they're not all the same. There's like a whole bunch of different variants of how things work. It's kind of a common core of like ANSI escape sequences. And then there's kind of the ANSI escape sequences sort of stopped getting developed sometime in the 90s, early 90s, I think was the last update of the actual standards document. And since then, terminal emulators have gone ahead and done all kinds of things with features like embedded URLs and all kinds of other stuff. And so terminals have lots of different things. So there's kind of a core set that's basically the same across a lot of different things, but not exactly the same because it was kind of a vague standard to begin with. And then you have like this whole set of extra functionality that's sometimes similar between different engines and sometimes different. And so it'd be very difficult to write a portable program that would sort of work across all these different terminals. We'd have to start doing things like bringing in the termcap library, and that really just makes a whole extra moving part in the whole system. So it's kind of tempting to say, what if we just define WASI as a fully virtualized terminal environment, where the WASI hosts will parse the escape sequences, and then they could potentially rewrite them to work properly on all the platforms they run on. So if you run on Windows, you can rewrite things to do the Windows thing, or you can do the Unix thing, or different kinds of Unix terminals. We can actually use termcap for you, potentially, to do these kind of things. So it's kind of tempting to go there, but it's also a lot of work, and it's also not clear whether there's enough demand that would justify that work happening. So that's kind of where that proposal sits. There's some ideas out there, kind of a lot of work to implement all this stuff, especially the escape sequence parsing, and it's unclear whether we'll actually do that work sooner or later. All right, so questions. Isn't there a 256 color option too? There is. I left that one out because if I recall correctly, that one is based on palettes. And color palettes are a little bit complicated. They have some state involved. We have to sort of set up the palette, and I didn't want to deal with the extra state, so I just sort of went straight from the 16 colors, which is the old school ANSI works everywhere thing, to 16 million colors or whatever it is, which at this point works in a lot of places. Like there's not really a lot of places that can do 256 that can't do 16 million at this point. So it sort of feels like we can leave out 256 and kind of skip the whole palette system, which simplifies it. We don't have to deal with the state of a palette. It's kind of my idea. But this is all just, this WASI terminal thing is just kind of me and my own sensibilities. So I definitely interested in kind of getting feedback on, like, am I simplifying too much? Or is this a good level? Or should we simplify more, potentially? We could even skip 16 colors at this point, because I think a lot of places have 16 million colors support at this point. It's pretty popular. And it's kind of a nice feature because the way it works is that you literally have an escape sequence that can embed RGB right there in the escape sequence. So it's like you don't have to have a special color table or deal with palettes at all. You just, like, you say, I want this particular thing, and the terminal will give it to you. And you know, we're not dealing with hardware terminals anymore. We're not dealing with kind of limited memory systems that need to have a color palette so they can compress their video memory or whatever. We're dealing with, well, almost always people are using virtual terminals today, and almost always those virtual terminals can just display whatever the color they want on the screen. So it sort of feels like we can just skip the 256 answer and go straight to the 16 million. That makes everything simpler. So that's my answer. All right. So that's WASI terminal. I also wanted to look at one other API in the stream, is WASI logging, which I haven't talked about yet, and it's in the CLI world. What's going on here? Oh, it's not even using the new directory layout yet. Okay, well, I gotta update this repo. This repo is kind of falling behind, but the great thing with this repo is that it's very, very simple. The logging API is very simple. There's an enum. So this is in the wit.md. So we got like markdown comments and then these wit code blocks. And then what the wit tooling parser will actually do is it'll actually just strip out all the markdown and just take the wit code blocks and then parse those. So if you just want to look at wit, you just think of what's inside these wit code blocks, and that's what actually gets fed to the tooling. So we have a level, which is basically, this is a pretty standard level. We looked at the logging APIs in Java and C# and Rust and a bunch of other languages, Go. And this basic set kind of is pretty common across all the systems. We have tracing, debugging, info, warn, and error. There are some systems that have like different levels of debugging or different levels of error, you know, like a serious error, less serious error. It seems like not all systems have those, and it seems like a plain error is kind of enough for this API. Just basically a judgment call. I think a serious error, to a first approximation, if you have a serious error, you should probably just exit. Like you log the error message and then exit the instance is kind of the default thing that most applications should do. That won't always be enough, but this is kind of enough to get started with. And then there's the log function. You made a log message. So we just call a function, you pass it a level, you pass it a context string, which we just don't assign any meaning to. You can basically put whatever you want in there that allows the producers of the log to give a little bit extra context of where this log is coming from, what the log might mean. And it doesn't mean anything to, like, in a spec way. But individual consumers might be able to do things like filter out content based on different context messages, or use it for searching or doing other things like that. And then message, which just does a string. And the idea is that each time you call log, it's a discrete log message. It's sort of like the JavaScript console.log function. Every time you call it, it's like, here's a message that's going to get ended in its own new line character. As that's there. And it seems like WASI logging is an interesting API because it seems like this is something that a lot of worlds are going to want to have. We're putting it in the CLI world because it's just useful to have WASM code that can just log stuff. It'll probably get dumped out to standard error. But it'll also be like, you know, logging in like the WASI cloud environment might want to have some kind of logging, and WASI HTTP client or HTTP proxy world might want to have its own logging. And every kind of world that we can think of that's being talked about right now, logging is kind of relevant, because like logging is kind of like just a fundamental property of software in a way. Like we want to have ways of, like, you're running software on some system, you want to find out what it's doing, what's happening, either for debugging reasons, you literally have a debug level, or just informational messages about, like, here's the thing that's happening that someone might want to know about, or warnings, like, here's something that happened that might be, someone might want to like be aware that there's this hazardous situation out there that I found out about, but it's not an error. And an error is like all these kind of things like apply to basically any kind of software that anyone will be running anywhere. And so it's really useful to have. So this logging API could potentially get pulled into lots of different worlds. All right. True color might be a better name than the very wordy 16 million colors. Yeah, it's true. I think true color is it is the standard name in like terminal lingo. If you look around terminal documentation, true color stuff is pretty common. I kind of don't like it because outside of terminal lingo, true color means different things to different people. 16 million is a lot of colors, but it's not more than that. And so true color suggests that it's like beyond human perception. And I don't think that we necessarily get there with what's true color is there, is my understanding. But I could be wrong. So maybe true color is a better name. Forward to seeing writing a tracing WASI crate based on this. Yes, that's definitely the idea. This log crate is supposed to be just this fully generic log thing, and the context parameter is just there for consumers to use however they want to use, producers and consumers to use however they want to use. So that lots of different things could get added to this. All right, so that's the end of the topics that I have scheduled to talk about here today. Tomorrow, we're going to talk about WASI sockets. That'll be a pretty big topic we can dive into. But for today, I guess I have two people still online here. Anyone have questions of people who are still with me here? Or any other topic that would be useful to talk about. So here I am, I got 10 minutes left on the stream. Ask me anything. Or otherwise, I'll just sort of talk about what I'm currently working on in WASI spaces. So right now, one of the things I'm working on, questions are coming in. Very excited for sockets. Yeah, that's going to be tomorrow. We got lots of different things to talk about tomorrow. It says something about super resources, or did I hear that wrong? So super resources is a thing that has been talked about in various contexts. And for a while, I think we thought we were going to do it. But subtyping is one of those things where I'm not a type systems expert, but every time I talk to people who are type systems expert and you say the word subtyping, they always get really, really afraid that there's lots of complicated things that happen when you get subtyping going on. The main use case we had for subtyping and for super resources was this pre-open case of being able to say you have a command and it can take a super resource of some kind of pre-open. And that way it's kind of like an open set. We don't have to have a fixed set of, like, I could take files and directories and sockets and nothing else. We could say, like, other APIs could come along and they could add kind of pre-opens you could take, which seems like useful functionality. But the problem is that that would require us to have some kind of downcast. Being able to take a super thing and be able to downcast to what is this thing actually, so I can actually work with it, right? Because if you give me a thing and I don't know if it's a file or a socket, I can't really work with it. Or if it's a directory, right? There's very few things I can do that are sort of general across all those three things. And the socket, maybe it's a connection socket where I can read write, which might be kind of like a file, but maybe it's not a connection socket. It's not connected yet. It's like I can't even read write on it. So I kind of need to know what this thing is. So I need to have some kind of way of downcasting. Which also means I kind of need to have a way of having hardwired into my program what kind of resource I'm getting. There's sort of no way for me to, like, dynamically accept a resource that I don't know what type it is and be able to work on it. All right, some good questions coming in. I'll get to them in a second here. And so the idea is, like, okay, this WASI command will have a variant that will kind of list all the things that we know about today. And we can add things to it over time as other kind of resources get defined, but it won't ever be helpful to have, like, new resources show up at runtime, because then that'll mean that programs will sort of be expected to handle things kind of dynamically, which we don't really have the ability to do. So a variant kind of is a simpler way to do it that also kind of covers the main use cases we have. And it avoids us from having to have complex discussions about subtyping and downcasting and when can you downcast to what? Like what ability do you have to see the dynamic type that you're downcasting to? Kind of my quick answer. Probably more coherent things could be said about that. I'm kind of like talking off the top of my head here, which isn't always a safe thing to do. Okay. If you thought about going more severe than error, I did talk about that just briefly earlier. I think my first approximation to that is like many systems don't have anything more severe than error. If you look at, for example, Rust, and I think if you look at WASI logging, in the README, we actually have a list of, looked at log4j. Log4j has fatal errors. It's like its highest level bond error that's fatal. But kind of the observation for WASI is that, well, if it's a fatal error, you just want to just issue an error and then exit. If it really is fatal, then that's what you need to do. The Rust log fate, there's no level higher than error. Python log levels, there's a critical higher than error. But again, if it's a critical error, what's the difference between a critical error and just an error where you exit? So that's kind of my rough thinking. Ruby log levels, see what do they have? They have a fatal error. I guess they do. There's a lot of things that have fatal errors. We could probably be convinced to add an extra fatal level. I guess here we have .NET has the same thing, critical error. Like I say, I addressed it here in the README. It excludes these fatal critical levels because the recommendation is to emit an error with the WASI exit and use the error level and use a WASI exit or actually just trap in that case. So I think the real answer to how we resolve this is to look at use cases. Like in what use case would you want to use a fatal error that wouldn't be well served by just issuing a plain error and either doing an exit or a trap? And if we have use cases, then that makes it really easy to make those decisions to go by use cases. Okay, will WASI be compatible with WASI-GC? Yes, it will be. It's not, the tooling isn't there yet today. Most non-web engines don't have GCs yet today. WASI-GC is largely motivated by the needs of browsers, which have a JavaScript engine, which has a GC already. And so the idea of WASI-GC is you want to be able to work with existing GC. In the non-web space, part of the whole idea is that we don't have a JavaScript engine there, so we don't have an existing GC. Now, there's work on adding GCs to non-web engines, and that will happen eventually. It's just not here yet today. But WASI is ready for it, because if you look at WASI, this is actually one of the big advantages of moving to the WIT IDL and the component model as a base, because we no longer have functions that take pointers, right? In Preview1, lots of functions, whenever you had to pass memory back, we just take a pointer to a buffer. And this basically just assumed that, like, well, of course, you're using linear memory, and you're going to pass me some integer, which is a pointer in its linear memory, and I'll be able to dereference it inside your memory. But with the WIT IDL, now we're not sharing memory anymore, not directly sharing memory, at least between caller and callee. And we have semantic, we have pass-by-value semantics, and then we have handle semantics. And so these semantics don't depend on, is something in GC memory, or is it in linear memory, or maybe someday there's another kind of memory that WASM adds, who knows? The semantics of it are sort of independent of where the actual value that you have lives. And so we'll be able to generate bindings for WASM-GC that can talk directly to WASM-GC objects. For example, the stream functions, if we go to WASI-IO, and look at WASI-IO.wit.md. So you look at read. Read doesn't take a pointer to a buffer to fill in. Read returns a list of U8. This will evolve as the component model gets support for real streams. This is sort of a temporary solution. But the big thing is that there's no pointer here. There's no kind of concept of, like, I'm assuming you're in linear memory, so I can write to your linear memory. It's just a list of U8. In a GC world, you can get your data back in a GC array. In a linear memory world, you can get your data back in a buffer in linear memory. And if you have any other kind of memory, we can generate bindings to that and other kinds of memory and be able to talk to that. So the answer is yes. The design here of WASI is very much anticipating WASM-GC coming and being compatible with WASM-GC. And actually, I haven't looked very closely at this and what's going to happen here, but there is someone working on Kotlin and looking at WASI and Kotlin together. And they're using WASM-GC, and I believe the main engine that can do that is Node. So there's kind of a question of how will this work there, and I think we'll actually get to see that prototype hopefully sooner rather than later with the Kotlin effort. I'm excited about that. All right. Yes. All right. So it's 10:58 in my local time here, which means we're at the end of my stream time. I'll be back tomorrow, same time tomorrow. This time we'll talk about streams tomorrow. And thanks everyone for showing up. Thanks for the good questions here. This is really great. The stream is also recorded, so people can come on and watch this offline if they want to hear me ramble on about WASI stuff. Here we go. WASI is just an interface independent of what the host or guest actually do with it. Yes. That is very much a design goal of WASI, is we just want to define interfaces. We don't want to define what kind of language are you working with inside the WASI module. It's language independent. And we also don't want to define exactly what kind of host you're running on. It's going to be host independent. So it's going to be portable, ideally across Windows and Unix, but also across other kinds of environments that aren't even Windows or Unix at all, look very different. And we're seeing kind of the rise of this interest in these kind of use cases with serverless and with embedded kind of use cases. All right. So that's kind of the whole story. I will see you all tomorrow talking about WASI sockets.